Okay, welcome. Welcome to DPRG's Robot Builders Night Virtual for October 13th, 2022. So Carl is not going to be leading this one. He has an anniversary, so we wish him happy anniversary, and so you have to put up with me for this meeting. All right. So we'll start off with the order. Ray's got some more advancements. Let's see what he's got. Go, Ray.
All right. I don't know if everybody saw the presentation I gave last week. Pat, were you here last week?
Yes.
Yes, I was here.
You were? Okay. I'm pretty certain Bob wasn't, but okay. Anyway, the color sensor seems to be working really well. It's simple. I don't have to do any adjustments to it. It works in bright sun, in shade. And I had experimented with, it just looks like a small piece of mirror, but it's actually, this one is a 630 nanometer bandpass filter.
Can you hold it up? Okay.
That's kind of what it looks like, a little glass square.
Okay. Is it stuck on a piece of paper or something, Ray?
Say that again?
Is it stuck on a piece of paper or something?
Yeah. Yeah, there's a piece of like clear plastic that's holding it to the paper. There's two of them there.
Okay, got you.
Anyway, so that lets light around 630 nanometers through it. So what I did is I glued it on the back of one of those 12 millimeter barrel lenses, kind of like the one that's stuck on the front of this sensor. And that's a global shutter sensor for the OpenMV. And thought that might have some advantages to being able to use a camera like the OpenMV or a Raspberry Pi to do basically to find the cone. So got it in there, started doing some experiments, and this, excuse me, is the results. I gotta present. Share. Okay. Shoot that down. Okay, can you see that?
Yep.
It's a program for, that's in the OpenMV IDE. You can see it?
Yes.
Yep.
Okay. Anyway, okay, gotta get some things going here. Okay, I'll show it in a second here. There is actually, I gotta turn the light on to get it bright enough in here because it's kind of dark. Okay, it's doing demo mode on me. Oops. Okay, oh, there we go. I gotta just move the light around. Get it more in the front. Anyway, so it's picking up. I don't know if you can see that image. It's not very big. It doesn't get any bigger. That's one of the cones. These are similar in color. This one is actually what I'd call more orange. This one is red. And by changing the threshold on it, it's a grayscale threshold. I can see more and more of the image. Like if I change right now, this is set to 90. If I set it to 64.
Yeah, grayscale would be all the colors of the rainbow.
Say that again.
I said gay scale would be all the colors of the rainbow.
All the colors of the rainbow, right? Anyway, so it picks up, you know, the light is here. This is actually some Gorilla Glue, which has an orange thing to it.
So you're using the camera through the 630 nanometer filter, is that correct?
Yes. Yeah, and that's why it looks so dark. It's just letting those wavelengths through. So it, you know, you don't see any color, and this is converted to a grayscale image pretty quickly here. And the advantage of that is you let the bandpass filter the colors of light through, and then you look for the intensity, and that's what this is doing when you move it to grayscale and set this threshold. So I want to highlight or see anything between 64 and 255 for the grayscale value. And all the other things are just to do with blob detection. So that one's, you know, it's finding that blob in these lighting conditions. What I can, well, actually I can get this, minimize this. You're not going to be able to, can you see out of my camera?
Well, we see you.
Oh, you do?
Yeah, you're there.
Okay.
And we're also seeing it looks like your desktop.
Yeah. Okay. But can you see the view of my camera?
No.
Oh, you can't. Okay.
The orange?
No, we can see the view of your camera. You're pointing at those cones.
The two orange.
Oh, okay. Yeah.
Okay. Okay. Yeah.
Yeah. Pointing at the two cones there, because just to kind of show their actual color. One is a lot, you know, very bright orange, and the other one is a reddish color.
Mm-hmm.
I think you can see that, right?
Mm-hmm.
Anyway, so the yeah. So if I point that down, those are the two colors that I was looking at. And the orange up here was actually the orange of the little box that holds the super glue. Mm-hmm. So it kind of works, but it is still a lot more difficult to use than the color sensor. The color sensor is dead simple. It works in a wide range of light conditions. I don't have to do any adjustment with it. The way it's set up, it, you know, like I said, it works in shade and bright sun, and I may have to look, like, I don't know if those, okay, last time, Doug, you said one of the cones was more of an orange.
Yeah, it's a little newer. It's newer than the other two, so it's a little more saturated, I guess would be the right word.
Okay, and you said one of them is reddish?
Well, to me it looks a little more reddish. Okay.
Oh, it does. Okay.
But it might be just the saturation.
Yeah, yeah.
The other ones look like they've been out in the sun a while.
Okay.
Yeah.
Yeah, I had I have another cone. That, I think this one was run over by several trucks. Anyway, it's more orange on the bottom, but it's got the, you know, the reflective tape on the top. So, so it sees, you know, it's not that different than the other one, which I don't think you guys can see now. You know, as far as orange color,
yeah,
at least on the bottom, and it detects, you know, the bottom part of that. Okay. So, you know, if those colors are close to what the cones look like, then it should work okay. So I think I'm going to go with the little color sensor. It seems to work really well. It's not that sophisticated, but it doesn't matter. It works really well.
Mm-hmm. Well, that's cool. Okay. All right, guys. So you finished, Ray?
Yeah.
All right. you know, always on these sort of things, a little peer review helps. So I did get a sensor from Adafruit.
Oh, you did?
Yes, I did. And I mounted it up in this little tube.
Oh, yeah.
And this is an idea that people might like. Does this look familiar, this tube?
No?
You guys must not be Old Spice people. This is an Old Spice tube that's been painted flat black with vinyl paint.
Yep.
And when you take the little screw mechanism out of it that's used to raise the deodorant up and down, you end up with basically a piston that can be used to slide up and down that. It's a really nice fit. So I don't know if you can see this, but okay, let's see if I can get it. Do you see? So there's the lens in there, and you can see the little thing. And I use a little, you could use a pencil, but I used a little thing that I happened to have around. I made a tool. I didn't make a tool. I just happened to have a thing that made a good tool. I could position the lens. Now, so that was really cool. And here's how and this is the sensor, and it's mounted on a 40 millimeter circle that's got 4
little nibs on it.
Nibs on it, you can see, and little braces for the pins to go out the back. So all very good. So if anybody if you want that, or I can give it to you. That's really, so that worked, you know, construction wise, it's did pretty good. And but it had this was actually part of a project I had kind of worked on something else. And it has you know, I think Ray's run into a couple of lucky breaks. I think he's using a plano convex lens, which I think is the right lens to use. Okay, now I have a biconvex lens on this, and they have I'm going to do a little presentation here, and if I can get to the right spot on lens selection. Well, this kind of talks about the different lenses that you have. So this is the one that Ray has, and you can see that the ideal conjugate ratio is all, where on the biconvex it's less, it's 5 to 1, less than 5 to 1. And what that means is that the distance from the light source shouldn't be any more than 5 times the distance of the focal length. Okay? And so that's so a biconvex is not the ideal lens for this, since we're looking at stuff that's 30 feet away and whatnot. Okay, all that said and done. So that just wanted to point that out. So I think Ray first lucked out. Since I know because I got a couple of them too. He just went to Tanner's, reached into a bin and said, "Ooh, they're only 20 cents. I can get 5 for $1." And he bought 5 lenses. So, so he just lucked out there. Okay, good thing. Now, but they will work with the convex lens, a biconvex lens, but I don't think the peak is as sharp.
Don't think the what is?
The peak.
The peak.
Yeah. Okay. So I'm gonna take this guy right here. He's got an Arduino on it, and I'm gonna start moving my camera around here if I get lucky. Let me open up a window. Okay. Is this open? Is it really doing that? Yeah, it's really doing that. Okay. So. Let me do this. Okay. Alright, so you can see here, this is just a serial port running on this thing. And now and if you look here in the distance, you can see that there's a cone on a stool.
Yep.
Okay. And I've got my little black cone from the Old Spice thing, and I'm going to slowly move it across it. And you can see it gets pretty good, then it gets low again. Now, so I'm going to, if I can, to get it there without it, that's this, by just leaving it there. Now, what I'm going to do now is I'm going to take a piece of cardboard and stick it in front of it, and you can see that's kind of the ratio that you're getting. Now that's probably less than 6 feet away, okay? And indoors. Now, so you can see it works for sure. Now I'm going to okay, I'm going to cut these all down, and so I'm not sure if you're going to be, I'm not going to know what I'm seeing, so you're going to have to help me here. So I took it outside.
Wow, you've done a lot of work on this, Doug.
And this is the setup. You can see there's a cone. That's 21 feet. And why is it 21 feet and not 30 feet or 90? It's just that that's where it was when I put in I was being eaten up by mosquitoes, so I was quick. This is my little laptop. Let's see if I can get to it. And you saw it was pointed at it. This was my outdoor readings.
Yep.
Pretty much. Now you see I've put the cardboard in front of it, and you can see it dropped. So I got about twice the signal, well maybe not even that, say 1200 by versus 950 outdoors. And that was not in the sun, that was in the shade. Now here I am, I'm slowly scanning it by, and you can see it picks, when it hits it, it picks it right up, and when you go past it, it really goes down. Okay? Now why is this low number? You know, what is there when I'm pointing at it and I put the cardboard, why is it still high? Higher? I'm not sure.
Maybe
I do
a little
have
orange in the cardboard.
Let's see if I can show it. See the red fence? The red fence right here? I think that it's not red, but it's reddish, you know?
Yeah.
And I think that may be doing it. Now, I found a signal on the red channel and on the orange channel that you could count on. So, you know, what I was doing was simply adding red and orange together.
Okay.
Just taking the two values and letting that be the signal. I think somebody who's a little more signal knowledgeable could probably extract the floor and could probably tell you how to peak it up a little bit. You know, I suspect there's two things that you need to do. Is whether you call it the floor or the bias, you probably need to figure out how to get rid of that. And then so maybe the answer might be that you pointed at something that's not the cone, you know, or when you're sweeping. That was the second thing that I think that Ray run into it. It is really hard to aim it, okay? And when you're aiming, it's like I say, to get that high peak, you really got to move it small steps.
Right.
And that brings
that's probably the only drawback. It's not the fastest sensor in the world.
Right. It takes 300 milliseconds to make a reading. So that means you get 3 readings per second.
Mm-hmm.
Okay, so the strategy of stopping, scanning, figuring out which angle you need to go to, turning to that angle, and driving to that angle for a set period before you redo it, and maybe get your distance sensors to, so that's kind of like how I first started off with 6 counts. You know, what I would do is, because I had no way to know distance, and I didn't, it would actually run, the distance could be further than my ultrasonic could pick up. So what I would tend to do is I would scan until I found which direction I needed to be, and then I would put in some, go 3 feet, and it would keep going. And if it picked up the if it picked up the ultrasonic, then what it would do is drive until it was a foot away, and it would sweep one last time to make a final adjust. So I mean, there'd be something like that, some sort of strategy like that probably. So like I say, I think the planar convex lens would help, and I think if you had a bigger planar complex lens, it probably would help too. But I'm not sure. So those are, so what I'm saying is, you know, I did a little work with mine, and I think you're onto something, and
Yeah.
it looks pretty good. So
Seems to work better than.
I mean, it's going to be a different.
anything I've experimented
It's going to be a different strategy.
Yeah.
Okay, and you do have to figure out, like I say, I did find, like in my backyard where I had that fence, you know, I could get high readings that weren't at the cone. Okay, so that's something, but you know, I said until I got the right lens in there, I wouldn't, you know, I'm not going to say anything about it, because the lens could be the whole problem.
So what? I didn't really follow. Why do you think the biconvex is not as good? Is it because it doesn't focus all the colors in the same place? Or?
No, I'm not a lens expert, but what they're saying is that if this is your lens and your distance to your light source, which is your cone, is greater than 5 times than the distance than the focal length, it's not ideal for it. It's not the best lens. Okay. Now, I'm not. Yeah, it did work. It's just not the best lens. And I think that, like I say, I think you lucked into that, and I think that was just, you know, good. You know,
little
good
did I know that day when I said, "Oh yeah, those look good."
Yeah, that's a good choice.
Doug, with that calculation, your 5-to-1, would that not be to get you a crisp focus on the cone?
I'm not sure what happens when you go beyond that. Okay. Like I say, you know, you still get it focused. I mean, think of it as, you know, you've all taken a magnifying glass, and when you're using a magnifying glass, what do you usually do? You put it on something and you get close until you see it. So you're actually within that 5x type thing, because that's about 1-to-1. See. So, but you've also got out there, I'm sure, and used it to start fires with, and you know, there you got a light source at infinity, and you know, you've got whatever thing, and it works, right? I mean, you can start a paper fire really quick. So I just think it's probably not ideal. And I mean, I'm going to just boot that over to the people who know more about lens than I do, which is almost anybody.
Yeah. Those little lenses have about a 2-centimeter focal length.
Yeah.
So, you know, yeah, if you're looking at, well, that's what I was thinking. You know, what's that circle of uncertainty? From what I understood, it was 10-foot radius, 20-foot diameter. So if you're on one edge of it and the cone is on the other edge, which it could be,
yeah,
you know, you've got to see the thing at least 20 feet away. So.
Or you got to have a search pattern. I mean, that's
Yeah.
most of the people in the past have used a search pattern,
Mm-hmm.
you know, of some sort, and
Yep.
and they're all using blob detectors, generally speaking. So
Right.
now on that line, I've started on this. I don't have it in here right now because it's over here. Here's my 4. I went ahead and got a fanless case, and I've got it now where I powered it off the battery. Everything worked. Case didn't get too hot. Thing ran for an hour with the model running with no problem. And so this was originally supposed to be a donkey car. So the question I'm having now is, do I want to how do I want to control the motors? Because my first thought with this particular setup, which is the little 16 servo I2C board that I think everybody knows about, and this, what I thought is, first step is I'm just going to make a follower. Otherwise, I walk around the yard with my cone, and the robot just follows me, and I know then that my model's good, everything's working all right. That's the first step, I think, on that. But I think I want, because I'm going to be having heading inputs from GPS and and a compass, a compass plus an IMU. That's going to be off the Bosch 055. By the way, did everybody get that message I sent? Okay, so people got it. Did you get it, Pat?
I saw them become available about 5 or 6 days before you posted it, and I had ordered them.
Okay, good. Because you couldn't get them.
Yeah, I thought mine had a robot shop in Canada.
Yeah.
And it was well worthwhile to get it.
Yeah, yeah. So anyway, I got, I'm going to have that input, and I'm going to have a GPS input. So I'd rather since my Python code is so crappy, I'm so bad at it, that I may just set up the Pi as a slave and just have it send its I2C messages to some, probably a teensy. That's what I'm looking at right now. Just send it to a teensy and do all the calculations in C and whatnot, and just that way I don't have to do any more on the Pi than what I'm doing. But I'm also trying to learn Python, so might be a good experience. I don't know. I think if this one we'll see. So anyway, I'm hoping. I thought I might have it this week, but I'm hoping to have a tracker next week, where it just follows it around, and if it works, great. So that's where I am on my projects.
I had a question about the Old Spice thing. When you were using it, did you kind of hear a little tune in your head, to do 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 do?
No. I don't even know if I know most of them aren't round anymore, but I believe you can still get the round ones. You still can get them, but you have to probably go someplace that has a good selection of their options. If you go to a grocery store and they have one type of Old Spice, you're probably not going to find the round one. And they also come in a short tube and a long tube, so you have to decide which one you want to use. This one was obviously a long tube. But it also has another nice little feature which I didn't mention. If you look at where is it? At the end, you can see there's a little lip around. So that is another thing that blocks extraneous light from getting down the tube. So it's kind of cool. I mean, it's like they were thinking about us. So
I guess you could go in and say, how much for the container? I don't care about the deodorant.
Yeah.
You know, I just want the container.
Yeah. So yeah, well, I tell you what. At one time, because I was doing this project I was doing it on, I actually had 2 or 3 of them because you know, I was thinking about making something that needed 2 or 3 of them. But then after a while, my interest in that project disappeared. Because what it was doing is it was housing an LED, which was shooting a beam across a room to, you know, be picked up by a receiver. So basically, it was like infrared, LED driven audio. But anyway, neither here nor there. So let's see. So that's all I've got. Okay, John, did you say you had something you want? Oh, you were going to show us are you at the point where your first robot is, your first Halloween head is ready to rock on the 31st?
Well, the first one, yeah, the first one I demoed before, and it's pretty much ready.
Okay, cool.
You know, I've got all the trimmings on it. I've got some last minute testing to do to see if there's enough. I've got some LED lights around the edges of the box that it's in. I've got to actually put it out front in the dark and see if it's got enough illumination. Plus to see if my porch light provides enough illumination to pick up faces. I may have to actually put in a brighter bulb, you know, for that. But the second pair of eyes that I was working on, I've got a video of that here.
Okay.
One second. Let's see. Here it is. So let me do a screen share. Screen. And grab the video here. So basically, I put my iPhone next to my face, and then took a video and moved around in front of it. You can see the eyes are following, but I've got, because I don't have the NCS2 compute stick attached, it can't follow very quickly. So I figured, well, rather than have a jitter, I went ahead and put a 2-second delay between detections. So you move your face, takes a couple of seconds, it moves. Move your face, takes a couple of seconds, moves.
Well, that might even be more creepy.
Yeah, actually, that's what I thought. Is it might even be creepier to have the eyes suddenly move, because when they're tracking you, it's kind of subtle, you know, with the original skull face. Yeah. But to have the eyes shift suddenly is a little bit more surprising.
Yeah. Oh, that's cool.
All right,
so is he going to be a skull, or are you going to make him something else?
I haven't quite decided just yet. I got to play around with a few things. The problem is that the skull face took quite a bit of customization to get to fit with the existing design, and so I have to do basically another custom job to get those eyes in another skull. So I haven't decided that yet. Now, on the second topic, and then kind of a segue, the first skull face that actually this one too, that I'm prototyping, I have a little control panel that I use to control a Raspberry Pi application. So that, you know, I can set the project up outside, out front, not have any keyboard or monitor connected, and just use my panel to determine to launch the application or to shut down the application, and maybe even to shut down the Pi. So a way to do that is, first off, let me share again. Now, I guess I shouldn't have terminated that. Let's see, hang on. Too many screens. Let's do a share again. can you see that circuit? Okay, so this is this little circuit board I put together. It's got two push buttons. One is for application control, so that when you push the button, it starts the app. If the app's not running, it starts the app. You push the button again, if the app's running, it shuts the app down. The second push button is for controlling shutdown of the Raspberry Pi. So when you push it, it starts the shutdown sequence so that you get a graceful shutdown without risking corruption of your micro SD card. Then, and this is really kind of overkill, I've got this two-position dip switch that I can basically enable or disable those controls. So if I didn't want to, accidentally shut things down, I can basically leave the shutdown switch open, so that disables the shutdown control. And then finally, I've got the LED status that basically tells you what's happening. This is what I call system status, is when this control app is up and running, it flashes this green LED, the D1 LED, every second. All right, just to let you know the Pi is still actually running something. Okay, the application status LED is a yellow LED. So if the application is running, and then this yellow LED flashes alongside the green LED to tell you the app's running. So that since it's a toggle, you need to know, well, is it running or is it not running? So that's what's going to do for you. And then the shutdown status is a red LED that once you push the shutdown button, when it initiates the shutdown sequence, it turns on the red LED to tell you that the Pi has been shut down. So now let me stop sharing here and switch, because I took your cue here on logging in a second time. You can see John G number 2. That's actually, I'm logged into the Google meeting from the Raspberry Pi 4. So let me go find that screen and see if I can share from there. It says your browser can't share your screen. Okay, fine. All right, we don't literally have to do that anyway. So let me instead, let's close that and do it the hard way. I have no idea why it couldn't share my screen from the Raspberry Pi. All right, so let's do it from here. Can you see my Raspberry Pi desktop with two black windows, two command windows?
Yes.
Yes.
Okay, so this is on the left side, this is the script. I'll call it run headless. Headless being, you don't have a keyboard or a monitor. And up front, you can see the definitions for the Raspberry Pi GPIOs, the physical pin numbers. So there's the mapping of the pin numbers, the two buttons that start and stop an application and request shutdown, and so on. So technically, if you wanted to reuse this, you can set it to any pins that you want to use. Got a timestamp function. And then there's a utility function here that checks to see whether a process having a given name currently exists, which is important because if you want to start the application, you have to come back and verify when you start it, when you spawn the process, you want to come back and check, is it running? Did it actually run? And when you come around to shut it down, you need to call out, you need to find this process and shut it down and verify that it indeed did shut down like you expected. So that's something that's a function I borrowed from posting on Stack Overflow. So I'm not going to go over the details there.
Yeah.
So when you run this thing, you say run headless, and then you specify with a dash A the name of the Python script that you want the run headless script to run. And I've got a test script I'll demo here in a second. There's also, and this is kind of overkill for most people, I've got this separate flag attribute for the, if you want to communicate to the application to instead of yanking instead of killing the process outright when you stop the application, I have an option where I just create what I call a flag file. And what the application does is it's constantly looking to see if that file exists in its main loop. And if it suddenly sees the file exists, then it gracefully shuts down and cleans up instead of requiring you to just completely yank the plug and leave something in a weird state. So let's see. So got a lot of in the main loop, and basically checking the switch status constantly to see if any of the if you enable the app or disable the app, or enable the shutdown or disable the shutdown. There's a little section for flashing the LEDs, and then here's the business end of it, where is if your app enable signal is low, or if the switch is on in this case, because it's a ground signal. What it does here, if it detects an event on this app control pin, that is, if you press the button that says start or stop the application, he goes and he checks to see, does this process exist of the given name, the application that you're running. If it's not running, it comes in here and it executes code to launch the application. So there it is right there, Python 3, and then the name of the Python script. Okay, then it verifies, okay, is it indeed running after I asked for it to start, and then it gives you status on, yeah, it launched, we're cool. Or it tells you it failed to launch. Okay, and then otherwise, let's see, forget that section there. We're not going to explain that. If the application is already running, this has to do with the flag file. I'm not going to, since that's just an optional feature, I'm not going to go over that. Then finally, down here near the end, if somebody presses the shutdown push button, all right, then he goes and, let's see, where did I do this? All he basically does here is he's going to set this flag. Sorry, this flag right here. Did I request a shutdown? All right. And if you look at the main loop says, as long as request shutdown is false. So for cleanup reasons, basically, I'm using that to exit the loop, and then the final act before run headless script finishes is to come in here and say, hey, is the app still running? Did we forget to kill the app? Let's kill the app first, with a hard kill there, and then he executes the system shutdown on the Pi. So that's basically it. Now, to see it in action, I've got a little test script, test.py, all right, and it's just real primitive. All it does is it's got a loop, sleeps every second, all right, and then wakes up. And this is, in this particular case, I've got one that checks for a file that I call exit flag, but that's not important. The only important thing here is I actually have a Python script that I can show. It runs it and then shuts it down whenever I push the application button. So if we go ahead and run it, say run headless. And my application is going to be test.py, and let's put it to the background. All right, so right away you get a log that says, yeah, the two switches are enabled, so we haven't disabled application start stop. We haven't disabled the shutdown button. And if we come over here and look for the test process, there you can see well, let's see. Oh, I haven't actually started it yet. Okay. Good point. Now here's where I need to bring, here's the complicated part where I need to bring the camera into view. If you can see. And I'm going to have to pick this up. Oh, it's flashing too quickly to see. I think. There it is.
Oh, I see a blue. I saw a green.
Yeah, but my frame rate is so slow that it's hard to catch it in time because it's only flashing for 1/10 of a second. So the green LED basically says the run headless script is running, but the test application is not running yet. All right. However, if I push this little push button, let's get that back up to the camera. If I push the application push button,
yep.
can you see both the green and the yellow flashing at the same time?
Yep.
So that basically says now the application is running. So let's go back to my other screen, and you can see here he says, oh, I've launched this test.py script. You do status area and it tells you what the process ID is. And if we look here on the other screen, now you can see Python 3 test.py. So basically, he started the Python script when I pushed the application button. So if I'm going to go ahead without bothering to mess with the camera view, I'm going to push that same button again. All right, and you can see he's pulled the plug on the test.py application on the left side. And you can see, yes, that process is gone here on the other side. And then finally, I could demo it, but if I press the shutdown button at this point, it'll just kill my whole window and you won't be able to see anything. And then the red LED will come on. But I'm not going to bother to do that because I want to keep this window open here.
Okay, that's cool, John. That's great. Yeah, let's make, if you don't mind, let's make that let's put that in the tutorials.
Yeah, I'll get the link right here.
Now let me make sure I understand one thing on your schematic. You're showing the double switches, but that's just because the little push button switches are double switches, right?
Yeah, that's just because it's one component.
Yeah. Okay, I got you.
So the switches really are independent.
Yeah.
So let me go ahead and post in chat the link to my GitHub page. That's where the run headless script is stored. The one feature that I don't have that I just thought of, well, suppose you have this control panel, you start your application, and then for some reason it dies. Well, I don't have that built into the script. I probably need to add that because you want to be able to see that yellow LED is flashing. Should tell you the application is still running, not just that I attempted to start it, but it really still is running. So that's something that I can add as an enhancement.
Okay, that sounds like a good thing too, because what I see the advantage of this is this will help somebody running their robot off of a Raspberry Pi. It's because they don't have, if they're nothing worse than having to drag around a VNC, you know, a laptop or something when you're out on a rover out in the middle of a field somewhere. What you want to do is be able to push a button and it goes. That's what you want, you know.
And that little board you saw that I had the schematic for. Yeah. That's something I had built by Oshpark from KiCad. So basically, anybody could take that circuit and then create independent push button switches, the switches and LEDs, make your own little board to do the same thing.
So how did you like what was it, Parquet? Where did you get your PCB done?
Oshpark.
How did you like it, the experience?
I have used the only other service I've used is PCBWay. That was on that project that I was working on with Murray. PCBWay, you know, they're a Chinese company. You have to wait a lot longer to get your boards, but they have a lot more things that they can do with your boards. Like you can specify 0.2 millimeter track widths and all sorts of features. And most importantly, if you need them to do the assembly, you can pay them to do the assembly for you. You know, you supply the bill of materials. Oshpark's more primitive, but it's really pretty easy to use if you don't need assembly. They're pretty straightforward, and they're fairly cheap and quick and fairly reliable.
Can you go ahead and put their link in the chat?
Yeah, let's see. I'll pull it up real quick. One second here. There we go.
Okay, cool.
Hey, Doug.
Yes.
Yeah, I think Kareem had a question last week, and I actually did go upstairs and put it down on the Can soccer course, the sensor, and I was using the AS7262, or is that the one you're using?
Yes, I have both, but I'm using this. I tried to, what I wanted to do, like I said, was just the exact same thing you did. Yeah. And I would have probably used the same lens. I think I've got them, except this one was already put together, and I said, I guess you didn't try it. So, yeah. Anyway, well, like I said, I found, I don't know about cans, I guess, but at 6 feet, it looked like it worked really well. Just the problem there is just timing.
Yeah, it's a lot slower than a camera would be. I think my experience was you get a lot of reflection off the can, and I have a, bamboo plank flooring, and it's got a lot of orange in it, or, so it seems to reflect the color of the can very well, and it ended up, looking at reflections as much as it looked directly at the can. And I think the situation, on Steve's property, you've got green grass. It's a nice non-reflective surface. It's not going to, there's really nothing that's orange around there, so it's a much more ideal situation for using that sensor in that application versus 6-can or can soccer. So if you had a mat you could put down that wasn't reflective at all, or to cover things that had orange in them, it may work better. But I think in this application, using it outside in, what's mostly green all around it, I think it's probably the best condition that it could work in.
Yeah. So. Well, I guess, like I say, that, I think it might be, I'm not sure I'd want to use it as my primary But it definitely could add. Boy, must be having a network problem because everybody's flashing up. Their video is paused. You guys are flashing like. Anyway, but I would think that. Yeah, could you make it work? Yeah, I think you could. I think that it would be something that would work. But like I said, I'd really like to talk to somebody who knew how to reduce the signal to noise ratio, and whether or not the 10 sensor one, which has, I guess, a few more
colors.
Yeah. See if that
Indigo and cyan.
Yeah. Well, I don't know if those would be ones we would want, but
probably not. They're on the blue end.
Yeah.
Yeah. It just seemed to work amazingly well, and it's like I said, it's not a camera with OpenCV or modeled with AI, but it works.
Mm-hmm. Well, sometimes simple is good. Yeah. You just have to. Like I say, you just have to give it a run. Like I say, I think there's a couple of things. Is your robot's differential, right?
Yeah.
So you don't have to necessarily use a servo. I mean, fine if you want to, but you could
steer it around with the wheels. Yeah.
And also, but I think that, like I say, I think the way you approached it, you ended up probably hitting the sweet spot right off.
Mm-hmm.
Yeah. Okay, who wants to go next? Anybody else have? Hey, Bob, I know this is your first time, but I want to, I see all of these wonderful robots in the background. You want to kind of give us a little tour?
I'll give you a background.
Okay.
My son is 23 right now, but when he was 14, I guess, he started writing a comic for Servo magazine.
Okay.
You guys ever get that magazine?
Yes.
The Max Robotech comics, right?
Okay.
So he ended up putting these robots in these comics, and then, I don't know, last year I said, I'm going to make the robots.
Okay.
So I started making the robots. And basically, so there's an R2-D2 in the background. That thing was built in 1978.
Oh, wow.
And it's radio controlled, and it still works fine. I was 17 years old. Kind of dates me, but it is what it is. But anyways, it went. It just was something that I did, and it was considered a robot at the time. But then I got into subsumption architecture in '94.
Yes.
And I did the 68 HC11 stuff, and did a very good robot and stuff, and did a bunch of different things. Then I used a basic stamp for a while. I liked it. I was able to do subsumption on a basic stamp.
Wow.
And it was good. It was actually worked pretty well, but but what ended up happening is the robot was very smart, but R2-D2 got way more buzz.
Oh God, yeah. We had a member who had I guess it was a life-size, it was life-size R2-D2. Had the big, I don't know if that one does that have the big aluminum dome head that's made out of aluminum? Yeah,
it's made from an old bank light, but so it's plastic painted.
Oh, okay.
Is that BB-8 back there actually functional?
That was one that you bought, and I was given to me for Christmas, and it never worked, but it looks cool, so I just sat on beside that robot. The other one still works just fine. But my son and I rebuilt that when he was 17, the R2.
Yeah.
We had a tape recorder. It was a tape player in there with a loop cassette that didn't work anymore. Radio control was just crash. I mean, I had to replace a whole bunch of stuff with them. And so anyways, we got it working, and that was, it was not working. It just didn't work well. And so that gets me into the Max Robotech comics. So then those robots were made to interact with each other. So what I ended up finding was I wanted to make robots that interacted with each other. Okay, so this is basically, I found that it doesn't work very well to interact with humans because the robots look like idiots. But if they interact with each other, then it would probably work.
Yeah.
Right?
Yeah.
They could crack jokes back and forth. So that's where I started on them. And so they're actually it's like I have to finish the bodies so the bodies look good. I mean, so everything's 3D printed. Like this is a wheel.
Yeah.
Yeah. It's got little things, and it just clamps on the wheel from Robot Shop, It works pretty well. And then this is the Servo City stuff. To raise the head up and down. This moves up and down. So I'm working on that kind of stuff. I'll present something just to give you guys an idea.
How did you attach the rubber part of the wheel to that large white wheel? Is it just, or is it Ninja Flex?
It looks like he
Real
has
simple.
a clamp.
It just clamps it.
Oh, okay. Huh.
So this is 3D printed.
Yeah.
And then and it's ABS.
Oh, it squeezes it. So yeah.
Squeezes it. Yeah.
But how did you get the rubber on the white part of the wheel there, or is that 3D Ninja Flex or something?
No, this is actually a tire that you buy for a powered lawnmower. I mean, a lawnmower that's got a drive system.
Yeah.
And I took it off of its hub and put it on this one. So.
Oh, okay.
Get an idea.
Yeah.
But
it's just kind of a friction fit.
It was printed to fit it.
Yeah.
Hey Bob, did I get you right that you said these are the characters in the comics?
That's correct.
Okay. So they got names, right? So do you know the names?
Bob, JJ, and Albert.
Okay. Okay. I see him now. He's a 6-wheeler type robot.
Yeah, 6 wheels. And all of the robots have different features. So this guy moves up and down he's got actuated wheels that go up and down, as well as a 6-wheel drive.
Yeah.
And all of the heads move up and down. So they're all actuated. The issue is I can't do any electronics until I have the mechanics done.
Yeah.
And I have to sand the mechanics and make them look cool.
Yeah.
Because otherwise they won't have the right features. But I did end up purchasing a ton of electronics and designing that stuff into. And I wanted to see if I have it here. Do I have it here anywhere? I probably do. Give me one sec. So right here. So I'll start sharing.
Okay.
Here we go. So I don't know why this didn't load. Should have loaded.
I don't know if anybody else has Googled that Max Robotech, but that's pretty interesting.
Yeah, there's a video on there on the R2D2 that was there. what I'll show, I'll do this. I'll just show you guys this.
I was going to say, if you have lousy bandwidth, it may not pull up.
Well, I have a good bandwidth, but I think the computer is overloaded with the other stuff.
Oh.
So these are different things that I purchased for the robots, like 35 kilogram servos move the wheels up and down. But then there's 90 kilogram servos that do the head here, and that one's 120 pounds that moves the head up and down. Otherwise, they vibrate, so you have to have a lot of power. And then this is an example of Bob's head, but my computer is overloaded, I think. But here is his head. It has these sensors in it, and the IR, sharp IR sensors, and then a 20-foot sharp IR sensor. And then voice recognition. And here's a camera that does, I guess it does all the stuff you need for face detection and recognition. And it tells you the age of the person, whether they're smiling or frowning, all kinds of things. Mm-hmm. And this is all built in to this head. And I was going to show that. Yeah, here it is. So this was loaded. So I've been working on putting all the sensors in and mounting it on the robot, which is in the background here. And I don't know if you can see that on the screen or not when I present. You guys still see my camera or no?
It's a little window. Yeah.
Yeah.
We can see you.
So basically, this is the same thing, but with 3D printed parts. Mm-hmm. So, so a whole bunch of this work was done last year, and then this year I started working it again. And so as soon as this is designed, which is not quite done yet, in Tinkercad, I don't know if you guys are familiar with it, but it's actually not hard. Not hard to use, but it can do all of this stuff. But all of the sensors have the screw mounts for the back, you know. So and they're all mechanically mounted, and then this is mounted to the frame. It's very detailed work. Let's just put it mildly, right?
Yeah.
And so it takes about probably another day, and I'll be able to print his head, you know, with both of those. And I have a few 3D printers. I print ABS most of the time, but I also have resin printers that I use. But basically, these take a long time to load because there are so many parts in them. So that's what it looks
like. You have a printer that prints fairly large pieces.
Yeah, it's 30 centimeters by 25 centimeters by 25 centimeters. And, but I've got two X Maxes from QIDI, and then I have some smaller ones that do other ones. I have access to 14 inches by 14 inches by 14 inches also, if I need to do it. And then basically though, I need Raspberry Pis connected to each other so I can run Mosquito so that I can have them crack jokes and all. And then, so you do scenario-based programming. And I have not done this type of work before. I mean, in other words, this is more ambitious than I've done in the past.
Yeah, it's pretty ambitious, I can tell you.
But I have an ultrasonic sensor company, so you can buy these little GPS modules that put out a heartbeat, but their heartbeat is identical, right? You don't have to use them for anything but the heartbeat for the time. Yeah. You put out a time of one pulse a second, right? And they're within a microsecond, half a microsecond of each other. So then you can put that in the robots, and they could know who fired what for that. And then that 3D, that forms a 3D, it forms a trilateration but it's a 3D sensing of where the robots are, and they always know where they're at and which side they're pointing to and how far away they are. And then the camera is only going to be in Bob, but he'll know where the people are and how far away the people are.
Yeah.
And he can understand the Raspberry Pi 4 can run real-time voice recognition of the English language faster than real time. Mm-hmm. So it's very fast using that re-speaker device. So, and it's very good.
Which software are you using for the real-time voice recognition? Is that Pico?
No, it's a script from Google. If you look up Respeaker and you go to their website, they will have a type on it. Okay?
Yeah, I'm familiar with that.
So I had it working. I basically have tried the different things to make sure they work, so then I can design them in. But the Respeaker, the best I'm hoping to do is just be able to pick up keywords here and there. Like if somebody says one of the robot's names, or if somebody says something, and then not respond immediately, kind of like the eyes were showing there, but have the robots talk to each other first and then respond. So in other words, this is a weird scenario, and it's called scenario-based programming. And you have to use state charts. And I am not sure, if they'll be running next year. I don't know. I'm guessing they might be, but I'm hoping to get the chassis printed by Christmas and the electronics mounted. That's what I'm hoping for. But I print with ABS solid. In other words, not hollow, just very strong. You could pound nails with it, if that makes sense. So then it basically becomes just like a cutting board, that kind of material. It feels like a cutting board. So you end up with these very strong chassis, because R2-D2 in the movies, when he falls on his face, he doesn't break, right?
Yeah.
And so that's the thing about it, is like these things, when I took the R2-D2 out and kids would climb all over it, it couldn't break, right? The 3D printed ones you make now, kids can't do that. It'll break them. This one was made out of wood, and it's got a wooden frame and a water heater body, and you could stand on it and get rides with it. It doesn't matter. Yeah. But it just uses window motors for it. So that's kind of what it is. It's a lot of I don't know how to put it, but there's going to be sanding on all of these parts and painting before I can mount the electronics. So it's kind of it's like I joined the club last year, then I had a standing meeting every Tuesday night from then on, and now it's basically done, so I can start coming to these meetings.
Okay, cool.
So, but I've been playing with these robots for some time. Anyway.
So did you say that R2-D2 is actually made out of a water tank, like a hot water heater?
Yeah, he was made in 6 weeks from the idea of wanting to make him till him looking like that, and it's made out of, there was a water heater standing outside, and I just pulled it, and it still uses the same cover that you pull off to set the temperature. That's in the back.
That's pretty good.
It's not as good as the R2-D2s that you see now, because they're all 3D printed and they're screen accurate. But but Star Wars came out in '77. This was built in '78. It was in time to run it at the second showing of a Star Wars, and then theaters would rent it from me during that time. It was fascinating. I did a lot of rentals with it at that time.
Yeah, but yours, you could still make a rusty cup of hot water with it, So.
Well, it's just the outside. Yeah. Yeah. It's kind of it's hard to explain. You just kind of like, how can I build this really fast? So it took like
Oh, yeah. Yeah.
3 weeks to find the parts, and then 3 weeks to put them all together. And paint was like the last week, you know.
Mm-hmm.
Yeah, I actually used a water heater as a trash burner. I call it Burning Man.
Okay. Yeah, that would work. That would work. Vent it.
Yeah, just plasma torched a door in it and welded hinges on it.
Yeah. What ended up happening though is I ended up getting a little bit soured from robotics when people didn't appreciate robotics like they did the R2D2. Does that make sense? I mean,
yeah.
You put all this work in, and you got this subsumption architecture, and the robot gets frustrated when you block it, and you get all these things, and it's working well, and nobody appreciated it, really. I mean, you guys would, but the standard people that I, with it was hard to explain. So,
well, like I was saying, we had a member who made an R2D2, and he would do just what you were talking about. He'd often go off, and I think he rented it, but he also would bring it to some of our events. And I mean, God, it was like kids just went absolutely bananas. It was just,
right.
I know he was constantly worried about it, not about him breaking, but, some kid getting run over or something like that. Because, like I say,
people's expectations are kind of high, aren't they? I mean, I built a giant Halloween robot spider that I showed the club last year with a glove where I could move the legs with my data glove. And the question I always ask is, well, can it walk? No. But they expected us, look, well, why can't it walk? Well, because I've only got these little servos in there that just are designed to move the legs, not to actually support weight. But they have high expectations.
Yeah, so I did end up, though, putting sensors on these robots in every area. I mean, they're just over-sensored, right? So that they can be around people. And that was a hope that I could do. I did get very good at radio controlling R2D2 around people, but at the same time, yes, he could run over somebody's foot and it would hurt because he weighs a lot,
Yeah.
And he did run, and sometimes I would just charge the crowd because it was too many people.
Yeah.
You had to push him out of the way, Yeah. But
that's a rude R2D2.
He was rude at times, yes. Yeah, and I would take him out on the street, but he could cause car accidents. Somebody's looking to the side, and then car accidents would happen because somebody's looking, and the other person in front put their brakes on to look longer, and they ran into the back. So yeah, I'm familiar with that, and so I'm hoping to end up getting some of that sizzle in these robots. So anyway.
Yeah. Well, when you put them on display, you should probably, you know how when you go to the conferences, they have backgrounds and whatnot. You should get one of those and make sure it has all of the comics on it so that they can see that it's characters from the comic. You know what I'm saying?
Right.
Yeah.
Yeah.
Because not very many people read Servo magazine.
No, I wrote the article, and my son would do the comics.
Yeah.
And he's a graphic designer now, so he got very good. He designs video games and stuff like that.
Yeah.
Video games. So, but that was his gifting, was that, and he thanks me for making him do that. At first, he wanted to do it, and then about 30 comics later, every month putting out a comic, it was getting old for him. But then he learned 3D printing through the process. He learned a bunch of stuff. He learned robotics. He learned a lot of stuff, right?
Yeah.
Programming. So he ended up having fun. It changed him. He didn't go to college, but he became, you know, he writes computer programs and stuff. I mean, he just does stuff.
Mm-hmm.
Anyway.
Well, thank you, Bob.
Yeah.
Okay, so moving to the next person I saw jump in. Hey, John, you got anything to show us this week? Anything cool?
Yeah, actually I
Just
do.
to interrupt for a second, I
Sure.
think Bob earned some kind of star there.
Oh, yeah. I don't know.
None of them moved, but
Yeah, so we can't give him a gold star. But Bob, I'm going to give you
I
a
do have
black.
videos, but yeah.
Yeah, but I'll have to give you a black star on this one. What that means is significant progress. Okay? But thank you.
So I remember Ray's thing of the other week. I saw this, so it's sort of interesting. So let me click on that. So there was this M&M candy store machine, and it uses OpenBC.
TV.
Yeah. So in here you'll see that it talks about, where is the list of items? A webcam, and the fact that I need light for it is pretty neat. So go through the colors and sort them out.
M&Ms and Skittles, but they do have a common problem, which is with these candies, there is just so much color, so much diversity. What if, just hear me out, they were more sorted into straight lines? Yep, that's better. Since it's 2022, machines do everything for us, and I do suddenly have so much more extra energy. So I use it to create this thing. I call it Get Cancelled Machine. First thing I had to do is figuring out a way to pick up candies one by one. For this, I designed discs with holes slightly larger than the candies. The candies sit on top of the first disc and drop to the second disc one by one through the white tube. The second disc turns step by step to show each candy to a sensor, and then drop the candies to the containers through the red tube.
Oh, hey, he could use a color sensor. He doesn't need a camera.
I don't know, he probably wants to go faster than 3 a second, though.
Oh, maybe.
Yes. Well, the main thing I thought was interesting was the fact that he uses a color range for each color. So that way it doesn't have to be an exact color.
Oh, wait a minute. He is using a light sensor.
Ah.
First algorithm that I tried uses RGB color space, which works by assigning 3 values for each pixel of an image. These values are red, green, and blue, and they have a range between 0 and 255. Here you can see different colors and RGB values that represent them. But since an image is not unified, I needed a way to find what the main color is on the image. Let's take this 5x5 image for example. For simplicity, there are only 4 colors on the image. What we can do is summing red, green, and blue values of all pixels and divide the sum to the number of pixels to find the average RGB value of the image. Now, how do we decide what color is this value? The way I did is by imagining RGB as 3D coordinates of X, Y, and Z. In this 3D space, we can use preset locations of each color that we want to sort and compare the distances between them and the average RGB value of the image. Then we can assume the smallest distance is the correct color. At least in theory, but in reality, this did not work very well. The main problem that happened was the stepper motors that spin the disc would get stuck temporarily, and the candy would not stop at exactly the right location. In this case, the average color of the image would be pretty much black, since the disc is black. So I made another algorithm that would work even if the candy is slightly misplaced. This time I used HSV color space, which again uses 3 values to represent a color. These values are hue, saturation, and value. With HSV, hue basically determines what color the pixel is. Here you can see by adjusting the slider, only the H value changes. With HSV, instead of finding distance in 3D space, I used filters for each color. What these filters would do is, turning all the pixels that satisfies a condition white and turning everything as black. The condition for each color is a different boundary. Here you can see I can separate the colors by changing the highs and lows of the boundary. So I found boundaries for each color and created the filters. Each image gets filtered for all the colors and turned to 7 different black and white images. Then what the algorithm does is counting all the white pixels for each of these 7 images, and the one with the most white pixels is the one that is masked by the correct colors filter. Now that the robot knows the correct container. The only thing that has left is figuring out what to do with all these candle boxes. I tried to play Jenga, but the first player always seems to lose.
Very fun.
So, I thought that was interesting.
Yeah, it's cute.
And the main thing is that, you know, it talks about ideal range of colors on that, because we know how with light and that colors can change.
Was that on Thingiverse?
That was yes,
Yeah,
it
it's
was
on
Thingiverse.
Thingiverse.
So yeah, it was a video. Yeah, it was on Thingiverse.
Do you know what the number is?
I can redig it up. Offhand, no, but I know where to look.
The color sensor would work good.
Hmm?
That color sensor would work well for that.
Yeah. Well, I don't know. Yeah. We're still playing on to try to figure out how to get this, the best signal out of it. Yeah.
In some ways, it's more complicated because it has six bandpass filters in it.
Yeah.
Rather than 3.
Right.
But it should work better then, not worse, right? I think.
Well, I don't know how flexible they are otherwise, how farther around the center of the band can the color be before it gets thrown in there or not? But it's interesting, Bob. You know, they make one that has 10, but I think one is infrared, and what's the other one? There's 2 that are really weird, so it's basically 8, if I remember right. John, you get that number yet?
Yeah, I put it in chat in the chat measure, so if you want to look.
Cool, great. Okay. All right, Kareem, anything happening with Iron Rain?
Yeah, they did a robot in 2 days, but they haven't put the video together yet, so it seems like a giant pile of homework hit them all, so yeah, might be next week.
Yeah. Did they ever work out the excavator video?
That is another thing that's gone into the slow pile.
Okay, gotcha.
Unfortunately, yeah.
Yeah.
They did release a spoof of the FTC game reveal that included the Mechavator in it.
Okay.
And so that's starting to make the rounds. But
can you send us the link to that, or?
Oh yeah, sure.
Yeah, or even show us that. How long is it?
It's like 2.5 minutes.
Go for it. Let's see what. For people who, Bob, that don't know, Kareem is a coach on First. Is that right? First team, and they're very, very talented, and they've done some wonderful things. So.
Yeah, let me go ahead and share that tab. This was a presentation they gave on it. And yeah, this is the game reveal. Well, let me show you this one first. I think I don't know if I showed this one to you before.
I have a challenge for all of you.
Oh,
Go to every computer in your house, your mom's, your dad's, your sister, your brother's computer, and must go faster.
Think they'll have that on the tour?
Boy, do I hate being right all the time.
Oh, so it is kind of a reveal, huh?
Yeah. So yeah, the slow reveal was not working well.
Yeah.
Unfortunately. So yeah. And that scene is again in the this is the longer one. That's the size of our robots normally. They have to fit inside that sizing cube.
A team consists of up to 2 driver-operators.
In this game, your robot is the protector of all good things. Ducky is an evil mastermind who has just come off a killing spree. Ducky is planning to overthrow the government. Ducky is a naughty boy who plans to set off fireworks on July 4th unsupervised within city limits during a drought. You must keep him secure. The play area consists of a 40 by 40 foot dirt field. At the start of the game, the robot must fit in a 12-foot cube but may expand to any size thereafter. The robot may not weigh more than 4 tons. The autonomous period starts with Ducky captured in an open 8-foot by 8-foot square prison marked by cones on the corners. Your robot must patrol outside the square, completing 1 transit of the perimeter. Your robot must not cross the lines connecting the cones or a major penalty will result from each crossing. Prior to the start of the match, teams may place their robot on the field at any position outside of the prison. Targeting the duck throughout the transit results in an extra 25 points. 20 style points will be awarded for scary behaviors while in transit that would intimidate Ducky into docile acceptance of confinement. During the break between the auton and teleop periods, Ducky escapes. During the teleoperated period, drivers will pick up their controllers and will hunt Ducky. Minor injury of Ducky, for example, scratching or light bruising, will be awarded with 5 points each. Death of Ducky will be awarded with 20 points, however bonus points will be awarded for style deaths. 90 penalty points will be given if you and your robot are outsmarted by Ducky like this, or like this, or even like this. Iron Rain was penalized for repeated brutal attacks on Ducky, expelled from the tournament, the league, and worldwide participation.
They are high school students.
Yeah. So all of this was done while you still had it, or did they do some sort of video?
Sorry. All of the video was captured while we still had it. So yeah, they were planning all of that stuff the whole time through.
Okay, I guess.
It just took them a while to edit it together, and the final technical reveal where they actually explain what it's doing and how it works.
Yeah.
That's the one that is less fun and taking longer.
Yeah. Well, that's cool. That's great.
And then this weekend they were, the new challenge was released, so their focus switched entirely to that, and they just like last year, they were trying to do a robot in 2 days, and they made one, and it works okay for something they throw together that fast.
Mm-hmm.
And they've filmed it, but they haven't prepared a video on it yet.
Mm-hmm. Have you got your course yet? Your practice course?
Yeah, we've got a we're putting a course together for one of the leagues, and we needed that for the Robot in 2 Days thing. So it's not fully set up, but it's a strange one this year. It's basically a cup stacking game. There's these cups that are about 5 inches tall, or cones. They're actually, they look like traffic cones, but they're hard. Hard plastic, and they have a hole through the center, and you have to stack them on top of poles of various heights, and those poles are like all over the field, so they're also a navigation challenge. Yeah, something like that. Yeah, a little bit smaller than those. So yeah, they're moving forward.
Okay, cool. Well, keep us updated.
All right.
Yeah. Let's see. Okay. Pat, you got anything? Okay. I don't think Dave has. Doug, how about you?
I have been busy working on formatting my Python program here to get the iRobot working.
Yeah.
This here, I got a cable, so that was good. But haven't been able to get anything to talk to the robot over the cable yet, but I think I may be getting close.
Okay. You know, I want to say there's a book that something called Making a Robot from a Roomba, I believe.
Yeah.
I want to say, if you look on, a lot of times you can get a used copy on Amazon for just dirt cheap, because it's a pretty old book.
I'll take a look at that.
Yeah, and it might have, I mean, because iCreate is basically a Roomba.
Right.
You know. Yeah. Okay, cool. Well, that also, you know, if you wanted to go to ROS 1, I want to say that they used Roomba. They used iCreates for that. The first.
Yeah, I don't think this iCreate 1 runs ROS, though. I think they didn't do that until number 2.
There's not enough horsepower on it, but what they do is they put a processor on it.
Oh yeah.
Yeah, and then run it. And they're called TurtleBots. I think they're up to TurtleBot 4 now.
Yeah.
Yeah.
Yeah, I've got a Pi I'm getting ready to do with it, but so far I don't have the program talking properly. I'm getting closer. We'll see.
Okay. What's the name of that book? I'm sure I had a copy of it somewhere.
Oh. Rats. It's getting closer. So it's actually, I'm working on somebody else's program and trying to work through some of the bugs that it doesn't work on my stuff. And I'm getting closer. It actually comes up on the screen now.
Okay, cool.
So we'll see.
Yeah. Yep. Okay, Dave, anything? Okay. All right, so we've gone through the list. Anybody else want to talk about anything?
Yeah, have you ever heard of a Vine robot?
Vine, V-I-N-E?
V-I-N-E.
Huh?
V-I-N-E, yes, correct. Vine robot. And it's something I found recently, a presentation for on the web. The reason I thought about it is, well, let me show you what it is.
Okay.
First. Let's see, get a share there.
This is a robot that can grow to hundreds of times the size, and it can't be stopped by adhesives or spikes. Although it looks kind of simple and cheap, it has dozens of potential applications, including one day maybe saving your life. This video is sponsored by Morning Brew, the free daily newsletter. Now, I made a video before about a soft truss robot, and this is also a soft robot, but very different in how it works and what it can do. These robots can be made out of almost any material, but they all follow the same basic principle. powered by compressed air. They grow from the tip. That's good.
Sounds like a balloon.
Pass through tight spaces and also over sticky surfaces.
Something like a car can get stuck there.
Well, I'm not going to show the whole thing here, but
Now, they do the same thing with the Vine robot. The robot is able to extend.
It can navigate this curving.
Only one of them finds somebody, but that's a huge success if it does.
But how do you keep a camera connected to the front of the robot when it grows out from the tip? Well, one way is to use an end cap, which allows that camera just to stay on the front, pushed from behind by the robot. But there are other mechanisms of attachment. The tiny wireless camera is mounted on an external frame, but this frame interlocks with an internal frame, which is actually inside the pressurized part of the robot body. It's similar to how a roller coaster's wheels go around the track. So this prevents the camera from falling off as the robot grows. What's really interesting is how the Vine robot can be actively steered. They attach artificial muscles to the robot. So the way this muscle works is that if you inflate it, it expands sideways, which leads to it contracting in length.
You don't have to use it much anymore because although it's soft, it's still somewhat stiff. So what we use instead are simply tubes of this ripstop nylon fabric with the braid oriented at 45 degrees. So in this sense, we just have one single layer of airtight fabric. This is the main robot body here. There were three.
no, I wasn't going to play the whole thing. Just kind of give you the idea. The reason I thought of it is my sister in New Mexico, she's in a group called Prairie Dog Pals, and what they do is they relocate prairie dogs from the city. Prairie dogs are pretty destructive when it comes to residential property.
Yeah.
So they trap them and they relocate them outside the city. And I thought, man, it'd be nice if you had a robot with, that could go down a prairie dog hole and actually navigate with a camera on it, and find out where the prairie dogs are, and then maybe map out the den so you can more easily retrieve them.
Yeah.
But it seems like it wouldn't be that hard to build one. It looks like there's not that many materials required, but might be a real challenge to try someday.
Yeah, when he was talking about that material cut on 45 degree, that's called cut on the bias, and it's a standard sewing technique. So something that people, if your wife does any sewing, she probably wouldn't know about it. If you do any sewing, you'd know about it. You know what I mean?
And I don't.
Yeah, yeah. You know how a lot of products have like a covering around the edge. That's the same type of material. It's cut on the bias. It's called bias tape. Anyway, kind of cool. Yeah, that opened up with some ideas. The problem is I don't like working with pneumatic things myself, but I can see where that would be great to get a camera down into a collapsed building, for example. That would be just perfect, because you don't know what paths are there, and they go from probably very small to larger, and you could just stick this in a hole and see if it got you anywhere where a person was.
Hey, maybe somebody will put a design for one up on Thingiverse.
Yeah, yeah. I was a little.
Yeah, I would think of colonoscopies. Might be the future method of doing colonoscopies.
Yeah. Ugh. But something like that. You laugh, Ray, but that might actually, because one of the things that happens with people that as they get older is their intestines and colon get very, very thin, and that's why they're saying that if somebody's over 75 and they go get a colonoscopy, it's probably edges on malpractice, because they'll probably end up getting a perforated colon
Oh, yeah.
You know, because it's very dangerous. So, anyway, you're right. This might, depending, you know, but, you know, again, I've always wanted to get one of those cameras with on the fiber optics where you stick it down in the sewer and you take a look at your sewer pipes to see if there's any cracks. But I know what would happen to mine. It would get stuck in there, and I'd have one of those things in my sewer pipe for the eternity. You know, I could never get it out. So it'd be fun though. Okay, well, nice topic, John. Anybody else got anything else? Yeah. I think it's 10 weeks now. 10 weeks to Robo Columbus. It's getting close, guys. All right. So anyway, hopefully we'll be seeing some stuff here on that soon too. All right. Okay. Well, I'm gonna stop the recording and say adios.
Okay.
Adios.
We'll see you next time.
Yeah.